Hi everybody, welcome to this talk on topology, specifically for computer graphics. So what exactly is topology? Topology is a term that refers to the structure of a 3D model and how it's constructed. There's several different types of CG objects that we deal with that require different types of topology. The major types of topology that we kind of deal with for the most part in the entertainment industry and games and things like that, we have deforming geometry and non-deforming geometry. So what is a deforming geometry? So we look at this guide here, we can see the cylinder and we see that it's deforming along this chain. And this topology is supporting that bend, whereas this topology doesn't work for a deforming bend. That's the major kind of difference here. So you wouldn't be able to really animate this, but you can animate this because the topology, the underlying topology supports that bend. Um, then we go to our non-deforming geometry, which usually is environment elements. This is a LiDAR scan that we can see here. This would be just a point cloud derived from a bunch of photographs. Usually with this type of geometry, we're not looking to change the shape of this. It's pretty much set. So we can, with this kind of geometry, we can kind of lean more on procedural methods. Whereas with the deforming geometry, we have to be definitely um, much more careful when dealing with topology. Can also be kind of confer or referred to as a hard surface topology. Um, and even within each of these kind of subsets of topology, there's more subsets even further on with that. So we can look at things like statues. So this would be non-deforming geometry. We definitely wouldn't want to try to deform this, but we don't need to because it's a statue. So the basic point is different types of objects will need different types of topology. It's not a one size fits all. It's not that you would retopologize everything the same. It's different depending on what the use is. Um, Here we can look at this is a deforming geometry. This is kind of a facial setup for topology. You can see the topology is following the muscles around the eyes and the nose and the mouth, these radial kind of fashions. And we'll talk about more with this later on. Um, and I think that's it for examples. We can go ahead and just jump right in. All right. So the first thing we need to do is kind of understand how the CG process kind of works from start to finish with retopology. And we're gonna go through a typical example of deforming topology just to start out with. So to do that, we are going to go into Bridge. So here we are in Quixel Bridge. This is a free kind of service. This is a tutorial unto itself if you don't know what Bridge is. I'll leave links in the description to more information about that. But basically, we need a model to start with. So I'm going to use this Roman statue head here. And basically, all you do, you go through, you download it. Um, in your export settings, you'll see where the stuff is going. So in my models, you can set all of your kind of presets and things. Again, this is not a bridge tutorial, so I'm not going to get crazy into that. Um, so let's go ahead and go into into Zbrush, and let's import that model. So I'm going to go to my Megascans directory, downloaded. We'll go into 3D, and I know there's a stone carved here, and I'm going to grab the high. Um, and just import normally. And here we have our statue. If for those of you that don't know, don't understand the Megascans workflow, just a real quick tip. When you're downloading your models, if you go to your export settings, so if you click this little thing here, go to export settings, and we go down to models, you want to make sure that high poly source is checked. Um, I have it unchecked by default. But you want to make sure if you're downloading one of these types of models from Megascans, make sure you get the high poly source. If you don't, you'll get a much lower res version, and it's not going to be what you're looking for. So just a quick tip there. All right, here we are in ZBrush. So in ZBrush, this kind of level of subdivision or of topology, you can see it's all just triangles that's supporting that underlying shape. So we definitely couldn't deform this. If we were going to use this as a statue, we could. We would just kind of we wanted to lower the resolution of this because this is a bit too dense for us. Right now, we're hovering like around 500,000 points. So we're going to step this through the process. So this is our sculpt res. And I'm going to go over to our subtools, and I'm going to duplicate this. And I'm going to rename this as well. So I'm just going to call this Retopo. And this original one, I'm going to call this sculpt data or scan data, whatever you want to choose there. So I'm going to go down to this Retopo. And typically what we would do first is a decimation pass. And the decimation basically it takes this input geometry and figures out how low res we can make this but still supporting the detail. So let's go ahead and do that. In our Z plugin up here, we have this decimation master. I have it docked over to the side. So I'm going to hit this pre-process current, and this is just going to process the scan data. Shouldn't take too long. It's pretty quick. So it's just taken kind of a snapshot of this. So now we can go through and figure out how much decimation we want. So right now, since we've got two of these, it's right around 500K. So how much do we want to decimate this? Let's just try it at its default and see what we get. So turn on polyframe and let's see what happens. We can see that was really fast. So if we're looking between the two of these, I'm going to hit this solo button here. So this is our original, this is our decimated. So usually we want to just look at this and see the difference, see if anything in the topology really changed that much. And I notice around the cheek. Let's see. Yeah, it's really not changing much, so I think this will work. And all really that does is just it lowers the poly count, the point count for us. So we went from around 500 to about 100, which is totally fine for what we're going to do. So now that we've got this decimated version, here's our scan. Just reminding you, here's our scan and sculpt. Here's our retopo. The next thing we want to do is retopologize this. So in ZBrush, we can do that relatively quickly. And I'm not trying to get the best retopo here. I'm just stepping you through each step of this process. So we go to Z remesher, and we'll just keep everything at default, and then Z remesh. See what we get. This shouldn't take too long with the model like this, and you can see that it's not terrific. It kind of messed the eye up. So this is a little bit too low poly. So we're just going to go over here to our target polygon count, and I'm just going to up this to say, I don't know. We'll just keep it. We'll say around 86,000 to see what we get. And I'm just messing with these numbers. There's no set rule or anything for these. Thinking, of course, it's going to take longer because we have a higher poly count, and there we go. This is more than good enough for a deforming geometry. But you're going to see that we lost some of our detail, and don't worry, we're going to get it back. So this is our base retopology. So if we go over here to our subdivisions, there's no divisions yet. So this would be basically like a subdivision level 1. So how do we get that detail back? Well, what we're going to do is project it. So we're going to go up here, and we have our original sculpt data. I'm just going to make sure that the eyeball is checked. Anything that's visible will be projected. So if you've got like 20 different subtools, make sure you only have the subtools selected that you want the projection to work on. So we've got a retopology. I'm going to go down here. We have this project button, and I'm just going to leave everything at default and just hit project all. And we shouldn't really see much, maybe a little bit of a jump, just to get some of that detail. Kind of came back up here in the hair, you can see it. But we still have our good topology, right? So now what we're going to do is subdivide, and we're going to subdivide this until we reach our target poly count, which was of our original scan data, which was right around 500K. So let's go ahead and hit divide once, and then we're going to hit project all, and then we're going to divide again and hit a project all. And we're up to 1.2 million, so we probably went one subdivision too high, but that's totally fine. We can always go back. So here now we've got, you can see we've got all of our detail from our scan, but we also have good topology here that can be deformed, and we have multiple levels of subdivision. So we can go down to this lower level of subdivision. This would be what you would export to Maya or to your game engine, and this would also be what you would be UVing. You can't really UV scan data without some kind of procedural tricks. That's the basic overall. So now we've got a low poly mesh and we've got a high poly mesh with good topology. So we've got both of these ready to go with multiple subdivisions, and this model is ready for production. So, and that's using ZRemesher. So now what we're gonna do next is explore a few different ways to do topology, because there's other software that we can use besides Zbrush. ZRemesher is a very quick and dirty, fast way of doing this. It can yield some pretty amazing results, but a lot of times you're going to want a little bit more control, and that's what we're going to get into next. Okay, here we are, Maya, with our scanned head here. This is not the decimated version. This is just the original from Megascans. So let's talk about how we would go about retopologizing this in Maya. The really the tried and true method here is to use quad draw, which is in the modeling toolkit. Let me just dock this over here. All right, here we go. Modeling toolkit. We have this quad draw tool. So first step, to use the quad draw tool, we need to make this scan data active, which basically means we can draw on it. So there's this little magnet button up here. If we click that, it turns it into a live surface, and you can see that it loaded our live surface into this attribute box right here. So now we can't really do anything to this. It's locked off because we need something, a geometry tool to draw on this. So let's start off with quick draw. And you can see out here I can't do anything, but over my data or over my scan, I can start drawing topology. So I'm not going to retopologize the whole thing. I'm just going to show you just how to start this and some of the shortcut tools. So how I typically do this is I plot my points first. So I'm just thinking about quads and how this is going to lay out. And I'm not going to go super detailed, super fast. I'm just going to go through and kind of get the major forms in, and I'm kind of always looking across the eye at these points because I want this stuff to all kind of join together. And now if I hold down the shift key, you can see we get geometry being drawn through here. And then we need to connect this up, so we're going to go there, to here, 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 here. Again, I'm just holding shift. To close the edges, I'm just going to move this point and it'll kind of click and snap. I'll snap one in here. And then I'm just going to hold down shift, which relaxes our geometry. Sometimes this works, sometimes it doesn't. I'm just going to relax these outer edges. And the relax just kind of gives you a little bit of breathing room in these curves. So you can see it's stuck right to our scan data. So next step would be to extend this out, so we can extrude by holding down the tab key. I think shift tab will do, yeah, we'll just use the tab key. You can do multiple loops, but I'm just gonna just do it like this. So I'm just going to kind of go up here to this next wrinkle, and then I'm just going to hold down Shift, or I'm sorry, Tab, and this is just going to extrude these edges out, like so. A lot of this gets down to personal preference on how you want to model. A lot of people like just drawing in all of their dots first. Um, some people just draw in a few dots and then start going into poly modeling. It's entirely up to you. So now we've run into this issue, like we've got smaller polys here into these larger polys. We can hold down the control key and it'll add a loop for us. And when I do that, you can see it popped out, so it's actually still sticking to that geometry, which is terrific. So again, tab, and I will link in the description, I'll link the shortcut guide for this tool because this tool definitely absolutely just runs completely off of shortcuts, which some people can kind of struggle with at first. And that's the basics. So if you want to delete a poly, hold down Control Shift, or an edge, or a point, or a polygon. Holding down Control Shift will delete those things. And you can see we can also add edge loops this way. So the general idea typically is to try to get your model drawn in with those points, and then depending on what you want to do, just filling in. So if I were to do this really quick, I'm just going to, just for demonstrations, just go ahead and just go through here. If I hold down Shift, just relaxing this geometry. Because the idea here is to have nice, even quads. Sometimes it's impossible, but you at least want to give it a try, because if this model were to form, like the eye were to blink, we don't want a bunch of extra geometry in there that would cause wrinkles and weird deformation and the likes. So that's one way that you can retopologize inside of ZBrush. The other way, let's make this not live again, so let's grab it. There are some remesh tools inside of ZBrush, or inside of Maya. They have moved around over the years. So we have this remesh and this retopologize. So these kind of work in conjunction. So typically in Maya, you're going to remesh. I'm just going to use the defaults and just remesh it. It shouldn't take too long. And basically all that remesh is doing is basically like decimation master. It's just giving us more, it's giving that poly data, right? So we'll just use this. We've got the remesh, and then we're going to go back up here and find it under our mesh tools. And then we have our retopologize right here. So let's just go ahead and run it, see what we get. This may crash, may not. This tool is definitely use at your own risk. If I was doing an automatic retopology, I would definitely do it in ZBrush. I wouldn't do it in Maya. But let's just see what happens. I'm going to pause the video while this runs through so you don't have to watch it. I'll be right back. Okay, so after about a half hour of waiting for that to finish, it did not, it failed. So I would just highly recommend not to use these automatic retopology tools in Maya. They're just not very good. As you saw inside of ZBrush, that remesh took about 30 seconds, as opposed to 30 minutes of waiting and still not getting the result. So I would recommend against it. All right. And then the last stop is I will show you an automated method of retopology inside of Houdini, just as an extra added bonus. Okay, here we are in Houdini, and I just have a file SOP with our geometry in here. This is just a bonus because I would probably imagine most people haven't used Houdini. I just wanted to show you kind of the possibilities here. So in Houdini, we have this thing called Quad Remesher, and just plug it in, select it, it does its thing. Just let it go. This usually should be pretty quick. And again, with something like this, if this is a statue, so it did a pretty good job, just default settings. Um, and then if we wanted to, we could project that detail back in here. But this could be a low res um, cage model. And there's all kinds of settings in here that we can use to get this better. But since I would imagine most people haven't used Houdini, I just wanted to show you the possibilities with this and how fast it is. It is really good. So for procedural retopology, Houdini is great, and ZRemesher is also a good option as well. And that's the basics of topology, folks. Thanks for listening. Bye.